Welcome. In this video I'm going to show you how you can obtain the Wilcoxon signed rank distribution by using the shift algorithm and R. I'm using Jupyter Notebook, but the code will also work in, for example, RStudio. I have a separate video where I discuss more about what Wilcoxon signed rank distribution is. I also have other videos, for example, by using my own library that simply has a function for it. But in this video, I'm going to explain how to use the shift algorithm to get, hopefully, that distribution. This algorithm was probably proposed by Strijdberg and Rommel and can also be found in, for example, Munzel and Brunner. Basically, it comes down to these steps, and let's go over these steps while we're at it. So let's say we have a sample size of 6. So let's say n equals 6. Then we start with listing all values 0 to the maximum possible of ranks. And that can be obtained by simply calculating this. So my max rank would be n times n plus 1 over 2. And I need a list going from 0 to that max rank. So that's our list starting at 0 and ending at 21. Then we create a vector with a value of 1 followed by n times a 0. So I need 1, so that's a 1, and then I need n times a 0, which is then actually the max number of ranks. So we get a 1 followed by all the zeros. Next, we need to shift all of these by 1. So this 1 should actually go at the place of this 0, which means this one will drop off, and then we put that one here. So we should get a list of 0, 1, and then all zeros. We can use tail and head for that, and that should give us nicely the whole list shifted by 1. Then we add this result with this result. So that should give me a 1 and another 1 and the rest all zeros, and there it is. Then we shift again, but now by 2. So instead of shifting by 1 as here, we shift by 2, and the maximum rank, therefore the header, goes also 1 down. So all of this should shift by 2, so these 2 should actually shift to these 2 positions, and the last 2 therefore get plugged into the beginning. So we should get 0, 0, 1, 1, and then all zeros. And indeed, that's what happened. We again now add the 2 results. So we add this one plus that one, which should give us 4 times a 1 followed by all zeros. And we actually keep doing this until we've done this n times. So here's the exact same code, just adjusting every time the number of shifts, and also of course in the head part adjusting it, and that gives us eventually then this distribution. And this is actually the frequency distribution for the Wilcoxon signed rank. I have a small animated GIF showing the result, GIF. The probability is simply now the frequency divided over 2 to the power of the sample size. So that's fairly straightforward. So if we have a t value of, let's say, 3, if t equals 3, then we should get a probability of 0.03125, so about 3%. So that's the probability of having a sum of ranks of 3 if the sample size is 6. The cumulative is easily found by taking the sum of all the sum of ranks equal or less than the t value. So we can do that in one go with R, and that's about 7.8%. Alright, I hope this was helpful, and thank you for watching.